All right. So for example number 4, we have a figure sort of like this, where we have two hash marks here. We have angle L, M, N, and O. And we're given a bunch of information. Okay. And it says, given the following information, line segment L and M is congruent to line segment L and O. M line segment L and M, then line segment M and N is congruent to O and N. Then angle M is congruent to angle O, and angle MLN is congruent to OLN. Prove triangle LMN is congruent to triangle LON. So to prove the triangles, we just have to prove that the corresponding parts are congruent. You're going to hear me say that phrase a lot. Because to prove triangles are congruent, we just have to prove that their corresponding parts are congruent. Okay? All right, well, what are we given? We're given that LM is congruent to LO, MN is congruent to ON, angle M is congruent to angle O, angle MLN is congruent to OLN, and then we need to prove that the two triangles are congruent. So now to do my proof, we'll do a little T-chart one. We'll have a statement here, and then the reason. And I'm going to write this kind of small, but basically for statement 1, we have LM is congruent to LO, and MN is congruent to ON, and that was given. Okay, and then they both share this line LN, and if you notice, they don't really say that's the third line, right? We know that LO is congruent to LM. We know that MN is congruent to ON. But the one thing that we don't know is that third line of the two triangles, which is LN. Both triangles share the line LN. So can I say that LN is congruent to LN? Sounds silly, but yeah, I can. How do I state that? That's a property, right? And that property, if you guys don't remember, is the reflexive property. So let me draw this little line here. This is reflexive property of congruence. Okay. And we'll put our little congruent sign. And then for the third step, I guess the other thing that I need to figure out is the angles. So I know that angle M is congruent to angle O. I also know that angle MLN is congruent, to OLN. And I know that because those were given to me as well, based on the figure, the way that the figure was drawn. Okay? All right, so what angles do I need to prove? In other words, I know that this angle is congruent with this angle is congruent with this angle. What's the last set of angles I need to prove? There's only 3 angles in a triangle. Well, I need to prove that angle MNL is congruent to angle O, oops, we'll just write that here, O N L. Oops. Wait, I wrote something down wrong. M, L, yeah, I did. I wrote this down wrong. This is congruent to O, and then angle MLN is congruent to ONL, or no, OLN. Right? That's this stuff here. So now on the fourth one, I need to say that angle MNL is congruent to angle ONL. Now, how do I prove that? It's a theorem.
Are you here for the hour today?
Yeah, how long have you been sitting there?
Since reflexive.
Okay.
Okay, because I got some questions for you that I can't find the answer.
Okay.
Thanks.
So now how would you do that?
Since M and O are congruent,
Is sure the line?
Hmm?
Is sure the line?
No, we're measuring the angles though. Think of it like this. I have a triangle that looks like this. Then I have a separate triangle that kind of looks like this. This is congruent to this. This is congruent to this. Now, I could write that angle, well, let's do it on another page. So I've got a triangle that looks like this, and I've got a triangle that looks like this. This angle is congruent to this angle is congruent to this angle, and so on and so forth. This is L. See how that looked? LMN? Okay. LMN. And then this is N, and then this is O, and this is L. Alright? Now watch this. If I say angle L plus angle M plus angle M and L, right? That's this angle plus this angle plus this angle. What should that equal? Yeah, that should equal 180. Now, if I say angle L plus angle O plus angle L and O, in other words, what I'm saying is this angle plus this angle plus this angle, what should that equal? 180. Okay? Now, because they both equal 180, what can I do? Well, I can say that this one, this would be like the first one and this one, I can say that angle L plus angle M plus angle M and L is equal to 180, but that's also equal to this, right? Angle L plus angle O plus angle L and O. Right? Now, if that's the case, right off the bat, I can subtract angle L. Those cancel, and I get angle M plus angle M and L is equal to angle O plus angle L and O. What do we know about angle M and angle O? They're congruent. So I could say angle M is congruent to angle O. What could I do?
you could subtract them from each side.
Yeah, we know they're the same numerical value, but maybe I'll say, yeah, so there's no confusion. I could substitute it in. So I could say angle M plus angle M, angle L, whoops, getting a little happy here with my writing, is equal to angle M plus angle L, M, O. Right? So I can justify substituting this in for O because they're congruent. Now I simply say minus angle M, and I get angle M and L is congruent to angle L and O. Now this is a theorem, and it's called the third angles theorem. So when I have two angles that are, if I have two triangles and two of the angles are congruent, you know, the two corresponding angles are congruent, then because of this, that third angle, those third angles will always be congruent. Does that make sense? Okay, so we would call this the third angle theorem. So now if I go back, I just proved that those do equal each other, and we'll call that the third angles theorem. And now I've proven, basically I've proven that all of the angles and all the side lengths are equal to each other. So I would say angle or triangle LMN is congruent to LON. Okay. And some textbooks will say, because the corresponding, we'll talk a little bit more about this, because the corresponding parts are congruent. It's the congruent triangles because the corresponding parts are congruent. But your textbook just says definition of congruent triangles. Okay? And that's our last example.